Right, I've got here a Soundcraft mixer. It's a EPM number 8. A mate of mine gave this to me to have a look at. He said it's not turning on, so no sign of life. He's just had it in storage, so it hasn't done anything. Shouldn't really have anything wrong with it. I mean, first thing we'll check actually is, I do hear something loose in there actually, but let's have a look at the fuse. Alright. So I don't know if you can see that there, but that fuse looks fine to me. I can measure it just to make sure. Because the fuse can actually look fine and still be blown. Alright. Yeah, so that fuse is fine. Right, so we'll pop it back together and see what happens when we turn it on. Alright, so yeah, I'm getting a little flicker on the phantom power there. I don't know if you can see that, so I'll turn the light off. So if I push this phantom power, you can see a little flicker there, so that looks like yeah, a bit of a flicker there, like it's trying. It looks like a weak power supply to me. Let's pop it open and have a look. I was hoping it wouldn't come down to this, but it appears that this is one of those units where I'm pretty sure I have to take off every single knob and button and every single, I'm not too sure, because like I would expect the back plate to come off to be able to service it without having to remove all of these buttons. But from what I can see so far, I've removed every screw. I don't think there's anything hidden there. Like this seems to be completely loose, this top section here. However, this bottom part's quite stuck on, and I can see some, don't know if it's clear on the camera, yeah, if you see in the light there, I can see some indents there where they've either spot welded or press fit some nuts that probably something screws into. So I do think that yeah, the circuit board's actually been screwed down to the board and everything has come off. So a little bit of extra work, but we'll survive. I'll just see if that freed anything up. It definitely, yeah, it feels a lot looser, but it's binding up here, so I'm pretty sure that I'll try and remove these screws and see if that's what's holding it on, and otherwise I'll have to take off all of these nuts as well. Yeah, they seem pretty stuck on. Little spanner for this. What do you reckon? Who's good at guessing their tools? That kind of looks like a 13 or a 12 to me. I'm gonna go with 12. 13. Alright, let's see if I can, is that washer magnetic? No. Kinda don't want to lose it. There we go. Now I noticed there's a bunch of these little plastic washers all over that as well, so I'm just going to see if it, yeah, carefully lift it off, and then I'll put these little plastic washers somewhere safe. Alright, so looks like we've gotten into it. This just definitely needs a bit of a clean. I can see a lot of dust in the faders. This can cause crackling, or I think these faders are buffered, so it means sound doesn't actually go through the fader. The fader just provides a resistance to the IC, and then the IC does the gain control. I think that's how it works. I'm not sure. This is quite a good brand. Soundcraft's a good brand for audio mixers, so that's how I presume it's going to go. So they won't quite crackle, but it can cause yeah, inconsistent volume control. So I'll definitely be giving those a clean. But the part that we're really interested in is the power supply, and it seems to be hidden underneath everything. So I'm going to take some more screws off and see if I can get the circuit board removed. Alright, so it seems to have loosened off the circuit board. Now what I can see is there's a plug here that's probably the power coming into the main board here. So I'll remove that. And yeah, there we go. So this is the main circuit board of the mixer. I'm going to assume, unless there's some broken potentiometers or anything, the mixer was still working fine according to my friend. So we'll just give this a bit of a clean, but let's have a look at this power supply first. Here's our power supply. Now I just noticed already there's some residual animal remains there. I think it's a that looks like the remains of a cockroach, and I can see quite a bit of that board's been hot around that area, and it seems to have arced. I'm not sure if it's arced. I'm wondering if this cockroach shorted something out. Let's have a look at what component got hot, because yeah, this here there's a resistor there, diode, not a resistor, and another diode. None of that really looks like it's gotten hot. I mean, that's black. Let's start out with just cleaning this up with a bit of IPA. Right, this is quite baffling to me. So I have I haven't really seen this before, where IPA doesn't clean up a circuit board. This must have gotten really hot, and like the pads, even the solder on the pads, it remains black. So I'm going to see if I can just reflow those two solders that have got black scarring on them, because they might be dry joints. I don't know at the moment. So I'll start by putting a bit of flux on. I'm going to do these as well because they seem to have sparked on something. I think this is where the cockroach might have gotten zapped. I don't think that's any tin at all anymore, eh? And it does not smell very nice. I think I'm going to desolder that and have a look at those pads. Really an awful smell coming off that. Alright, so there we have what was the resistor. It's like a high wattage resistor. I'm having a bit of a hard time reading the color codes on it. I'll see if I can, I haven't got a microscope yet. It's kind of the next thing on the list. Very hard to read the color codes on that. I think I might go and I'll measure it now and see if it's still got any resistance. And yeah, we'll try and figure out if this resistor's still alright. So that's coming out at 3.8 mega ohms. I've had a little bit of a look at the circuit. I managed to find a circuit diagram. So this resistor that has failed, it's a VCC bootstrap resistor. It's exposed to 175 volts DC on one side and then a small signal on the other side. It's supposed to be 150 kilo ohms. So I'm going to assume that this resistor has failed. Now, I saw some information online about these power supplies specifically failing in this way, where you see this diode heats up and ends up failing, and it's caused by these two capacitors drying up. It's a very common problem on this type of power supply. So what I'm going to do is I'm going to definitely replace these two capacitors, and I'm going to probably replace the Zener diode as well, just to be safe, because apparently eventually it gets so hot the Zener diode goes as well, and then I'm going to assume that this resistor has failed, and I'll test some more components as well just to make sure that these other resistors and diodes haven't catastrophically failed. So the Zener diode right here has definitely failed. It's dead short. What I'll do is I'll desolder it and measure it out of circuit, because there could be contributing factors to why it's measuring 0, but I'm pretty certain this diode has failed. I don't know if you can quite see it there. There's another small diode here that seems to be operating as expected. It's got a nice 0.5 volts forward voltage there, and if I measure the other way around, and the diode seems to be blocking. So that diode seems to be fine. It's the small orange one and marked D1 and D2. It seems quite low. 0.07 volts is quite low. Let's see if this diode is blocking. So I'm going to remove that diode from the circuit as well and verify that it has indeed failed. I'm pretty sure it has failed. It shouldn't be conducting 0.7 volts. It doesn't. If I look at the circuit here, yeah, it doesn't seem to be in parallel with any resistor or anything, so that diode should be blocking. I'll remove these two diodes and measure them out of circuit. Alright, so we have our big Zener diode and our smaller diode here that seem to measure up incorrectly. I'll just measure now the forwarding voltage on this. 0.4, that's quite normal. Now let's see if it still blocks. Right, so this diode seems to be okay. It was purely this circuit causing the strange reading I was getting. Now this Zener diode here, seems to be dead short. Yeah, this Zener diode is no more. It will have to be replaced. So I'll reinstall this diode back into the circuit because it doesn't need replacing, and I will try and source another Zener. Right, so got the parts in today. I ordered everything from Diggy. I needed some more stuff, so it's not a sponsored video or anything, but I just found them the most convenient supplier that had everything. I need some parts for some other projects as well. So this one here is the Zener diode, 100 volt, I believe. What is it? Yeah, 100 volts, 5 watts, 5% tolerance. So that will go in there. And then the resistors I ordered are a little bit too big. I didn't, on the circuit diagram I had, there was no wattage rating, so I just found the ones with the same resistance with the highest wattage I could find, and these ones, they're a little bit bigger than the original, I believe, so shouldn't be a bad thing. Smaller is where you should worry, but quite jumbo sized. So that's that there. I ordered some spares just in case something goes wrong and I blow everything up. These are the capacitors. These are from the Worth brand, which was recommended by a someone else that had repaired a board with a similar board with a similar issue. This is actually where I got the schematic from as well. So these should be rated for a higher temperature and a higher lifespan. I don't think these will go bad anymore in the lifetime of this mixer. And yeah, so hopefully if I put these parts in, that should alleviate all of the issues, and no op amps were blown in the main mixer, which apparently is another problem caused by a failing power supply. So we'll look into that after we fix this power supply. Alright, so I get these two capacitors off that have dried off. I found a little guide of someone on the internet that had these power supplies fail, and they say commonly these capacitors dry up, and it takes out that Zener diode as well. It makes the power supply really inefficient and heat up, and it's taken out this 150 kilo ohm resistor, one that I ordered too big as well. Yeah. Looks like they're a little bit too tight on those pads. These are much higher quality capacitors. They're the same ratings, just slightly better temperature lifespan. So yeah, they're going to sit. Ah, there we go. That'll do, donkey. Snip the extra leads off. Cool, so those are in there nicely. Next up will be this resistor. I've already put the, I think these are ceramic or plastic little spacers, heat resistant, just to keep it a little bit off the board, because this resistor obviously gets hot, and yeah, you want to give it a little bit of airflow so it doesn't cook itself. So I go in there nicely. And now last we need to get that Zener diode in. So I managed to find an identical replacement. So it's the good part about using a website like DigiKey, like I'll order a whole bunch of parts so I can get the free shipping for several projects at the same time. It actually saves a lot of money, but they have a pretty wide range of pretty much anything you could need. The only thing I had a bit of trouble finding was these older, I've got a project that needs these TO3 MOSFETs. Let's see if I've got an example here. It's, these ones. This shape's discontinued apparently, and I couldn't find any of those. They're more of like an eBay kind of thing to find. But besides that, they've got a range of pretty much everything. It's in there quite nicely. A little bit of flux. Now with these bigger components, they've got quite large legs that soak up a lot of heat. It's important when you solder them to get them nice and hot, so you don't get a dry joint. if you don't get one of the parts of the material that you're soldering hot enough, what you get is the solder will attach to it, but because the part's so cool still, it'll cool down so quickly that you get one of those foggy looking solder joints, and it's a known point of failure on any circuit. It's called a dry solder. It just cools down too quickly basically and doesn't get a chance to set properly. Trim off the legs. Alright, so that should pretty much be this power supply back in action if nothing else got eaten by the failure. Alright, so we're ready to give it a test. I've got my copyright free lo-fi beats playing, and what we're going to do, so we've got a gain here. Oh, I just had a bit of a power surge there. So it's got a little bit of channel bleed coming through this. We don't seem to have any volume control over left, so that might just be a buggered fader. Yeah, so channel 1's see if that carries over to the next channel. Yeah, so we're still getting some channel bleed onto the left channel. No response really on that left fader. I'll have to figure out what's going on there. It might be something for a next video. That's no longer power supply related. That'll be something in either this fader being bad or a dip mention in some of the posts online about these mixers that when the power supply fails, it takes out some op amps. So I might check out those op amps and see if there's anything that's been damaged there. But again, no issues on channel number 2. Channel number 3, 4, 5, 6. Oh, we have nothing on channel 6. This is something else to have a look at. Channel 7. Oh, channel 7's noisy. And channel 8. Yeah, I think that sums it up for this video. We will sort out the actual audio mixer issues in a follow-up video with this. So yeah, don't forget to like and subscribe if you like my content and my videos. I'm going to try and get more professional about this. These are my first couple of videos. I'm just kind of testing the waters. But yeah, let me know what you think.